Alright, today we're going to take a look at lesson 105. We're going to calculate the surface area of a right solid. We've calculated the surface area of a rectangular prism, but not necessarily other shapes, so we'll cover that today. We're also going to calculate the surface area of a sphere, covering the outside of, say, like a tennis ball or something. Alright, I would like you to find the surface area of this shape with me, this rectangular prism. When we've done this in the past, we have listed the faces. Let me get a pen here. The front and the back, the left and the right, and the top and the bottom. So we have front, back, left, right, top, and bottom. Okay, so let's take a look at the front. The front is a 7 by 5 rectangle, so 7 times 5 would be 35. That would be both the front and the back. All right. Then we've got the left and the right. So let's take a look at this side panel here. We've got a 5 by 4. 5 times 4 is 20. That's the area of that face. And then the other side would be identical to that. And then we have the top and the bottom. It would be 7 times 4, which is 28. All right. So once you list all those faces, then I would like you to go ahead and use your calculator and find the surface area for that entire rectangular prism and include that with your practice set problems that you'll do later. When you're done with that, then you can go ahead and start the video back up and we'll continue on to a different kind of solid. Alright, here we have a triangular prism. Now this one has 5 faces. You have the 2 triangles and you have 3 rectangles. And the 3 rectangles are not necessarily all congruent. So let's take a look here at the 2 triangles. The triangles are congruent, so if I find the area of one, I'll be able to find the area of both. So we know that with a triangle, it's base times height divided by 2. And in this case, our base and height are 4 and 3 divided by 2. So each triangle is 6. So I have 6 plus 6. That's our 2 triangles. Okay. Then our rectangles. All right, let's look at this back rectangle. This one right here is a 3 by 6 rectangle. So we have length times width, 3 times 6, that would be 18. Okay. Then we have this bottom rectangle here, which would be 4 by 6, so that's 24. And then we have one more rectangle, which is this front face here. And that would be 5 by 6, which would be 30. If I add all those up, let me run that on the calculator. So I've got 12 plus 18 plus 24 plus 30. That gives me 84. And it is going to be square feet because we are still talking about area. So if I were to cover the outside of this triangular prism, I would need 84 square feet of material. Now, I'm going to show you a little bit of a shortcut for this that will help you if we were encountering a different triangular prism. Okay. I'm going to introduce a little bit of a different term, and that is something called the lateral face. The lateral face would be those rectangles that connect the bases of a right solid. So in this case, it would be these 3 rectangles. On this back side, it would have been the 3 rectangles that we found the area for. Okay. If you find the perimeter of the base, so you'd find the perimeter. Let me go up here where it's all. So if I find the perimeter of this triangle and I multiply by the height of the solid, that will give me the surface area of the entire solid. Because think about it. If I took this times the height, this times the height, and this times the height, that's how we found the area of the 3 rectangles on the previous slide. So if I add those 3 together and then take it times the height, that will give me the surface area. Now we're going to go back to the previous slide. I want you to keep that 84 in your brain that we got as our answer. And let's try our new method and see if we get 84. All right, so just to find those 3 rectangles, I'm going to find the perimeter. So I've got 3 plus 4 plus 5. Okay, so that's 9 plus 3 is 12. And if I take that times the height, okay, and you got to think of it standing up on its base because the base is a triangle, times 6, that's going to give me 72. All right. Then if you remember when we had found the height, or I'm sorry, the area of the triangles, they were each 6. 6 plus 6 is 12. That got us the 84. So a much shorter version of how to do this. Again, you find the perimeter of the base, and you take it times the height. That will give you, again, just the area of the lateral faces. Then you have to find the area of the bases themselves. All right, let's try that with a cylinder then. A cylinder, the lateral surface would be like the label in a soup can. So if I find the perimeter of the base, well, perimeter of a circle is the circumference. So I've got circumference equals pi times diameter. Let's use 3.14 for pi times 6. That gives me the area, or I'm sorry, that gives me the perimeter being 18.84. Then if I take that times the height of the can, that will give me the soup can label. So 18.84 times 10, of course, is 188.4. Now that means we have just found all of this. We found the soup can label. If we're going to find the entire surface area, then I need to also include the two circles. Well, to do that, we have area equals pi r squared. That's 3.14 times 6 times 6, which is 36. 3.14 times 36. 113.04. And we have two circles. We have the top of the can, and we have the bottom of the can. So 113.04, 113.04. Let's see what happens when we add all those up. So 188.4, 113.04, 113.04, and it gives you 414.48 square centimeters. All right, that is the surface area. Again, to find that lateral surface, we took the perimeter, which in this case is the circumference, and we took it times the height. And then we added in the two circles. All right, so let's now take a look at how to calculate the surface area of a sphere. You calculate the area of the largest cross-section of the sphere. Okay, so think about slicing an orange right down the middle. Okay, the circle that results there is the largest cross-section of that sphere. And the surface area of a sphere is about 4 times the area of that circle that you got when you cut the orange in half. Okay? So, since we know that the area of a circle is pi r squared, if we take that times 4, that will give us the surface area to cover the outside of a sphere. All right, so let's apply that to this tennis ball then. And I would like you to do this one with me. So again, in your practice set, would you work this with me? A tennis ball has a diameter of about 6 centimeters. Find the surface area of the tennis ball to the nearest square centimeter. Well, again, to find that surface area, and a lot of times we'll do this, we'll do an A with a small s for surface area, equals 4 times the area of that circle. Okay? So, surface area equals 4 times 3.14 times the radius, which is not 6, it's 3 squared. So 3 times 3. So we have 3 times 3 is 9, 9 times 4 is 36. So we have 36 times 3.14. Again, I would like you to just write on your paper exactly what I'm doing right here. 113.04 square centimeters of surface on to cover that tennis ball. All right, one more slide here. Actually, no, that's the end. What I would like you to do now then is go to practice set B, C, and D. If you do B, C, and D. So don't pay attention to that slide I just showed you because one of the things was wrong. So you need to do letters B, C, and D only. and then bring it to class tomorrow.